And so I want to point out when we start working with squares and square roots. When you square a number, you multiply it by itself. So if I'm asking you to square 10, I'm asking you to figure out what 10 times 10 is. If I'm asking you to square negative 2, I want you to find out what negative 2 times negative 2 is. Making sure that you square your negative properly. If I want to know what 1/2 squared is, I want 1/2 times 1/2, 1/4. That's what square is. The square root is different. And we're, again, going to be working with both of them. So we're going to do some squaring practice here. 3.1 squared. On your calculator, most of us have a square key. So 3.1, mine on these blue calculators is right next to the 7. And so I just have to hit that key and it'll show a little 2 for me. If you can't find your square key, let me know. I can tell you how to do that. Everybody's calculators are a little bit different. But when I hit enter, I get, in this case, 9.61. Yes. Okay. Let me pause this for a sec. Sometimes, however, you're not even going to need your calculator. Sometimes squaring goes fairly quickly and fairly easily, and some of the easiest things to square are square roots themselves. The square root of 3 squared means the square root of 3 times the square root of 3, which equals the square root of 9, which then becomes what? 3. So when I square a square root, what it actually does is it undoes that square root. It's like when you're solving an equation and you added something to the variable and you subtract to undo it. That's what a square does to a square root. So if I had the square root of x equals 4, I can square both sides to undo the square root. Okay? So squaring undoes a square root. So when I look at a problem like this next one, the square root of 23 squared is just 23, done and done. Square root of 15 is just 15, done. What happens if they stick a number in front of it? Well, then it takes a little bit more. I have to think of this separately. I'm going to think of this as 7 squared and the square root of 2 squared. Bless you. So the 7 gets squared, 49. The square root of 2 gets squared, 2. And then when I multiply those together, it's 98. Or, if I'm going to use my calculator, I would have to put everything in parentheses. 7 square root of 2. It'll open the parenthesis for the square root, end, and then square it outside. Notice how I plug that in? And it will give me my final answer. But usually I don't count on the calculator too much. I will just square the front and square the square root. Is everything okay? Oh. Okay. All right. So what's the next one? 3 squared times the square root of 11 squared. What's 3 squared? 9. What's the square root of 11 squared? 11. What's 9 times 11? 99. Beautiful. Easy one. 61. Last two are not so easy. Give them a try. see what you get. We'll check your answers shortly. Then we're going to talk about Pythagorean theorem. For the first one, I squared 2, got 4, squared the square root of 17, got 17. 4 times 17, I got 68. Do we agree?
Yeah.
Okay. Next one, I squared 6, got 36, squared the square root of 5, got 5. 36 times 5, I got 180. Do we agree?
Yeah.
Looks pretty good. All right. Let's talk about the Pythagorean theorem now. We're all ready. We know how to work with our square roots. We found our things on our calculator. Now let's start putting stuff together. So first of all, one thing that I need to know is the Pythagorean theorem only works if you have a right triangle. And the indicator that I have a right triangle, remember, will be a little square in the corner. That is the perpendicular symbol, actually, and it tells me that these two lines or line segments are perpendicular and therefore they form a right angle. Surrounding the right angle are the legs of the right triangle. I have two of them, leg 1 and leg 2. Sometimes I'll refer to them as the shorter leg and the longer leg, unless they happen to be the same size. Then I can't do that. Then the legs are equivalent. But right here, I'll just call them leg 1 and leg 2. This is a subscript. It's not like a squared or anything. This is the first leg, so I put a little 1 underneath it. The second leg, kind of like our x2 minus x1 stuff. All right? The longest leg, which is always across from the right angle, and I wrongfully called it a leg, the longest side, which is always across from the right angle, is called the hypotenuse. That's Hypotenuse, hypotenuse. So the Pythagorean theorem only works if the triangle is a right triangle and the sum of the squares, oops, sorry, hold on. It can only have the, let's do the sum, or the, I don't think this is written right. The square of the, let's change that to the square of the hypotenuse. The square of the hypotenuse is equal to the sum of the square of the legs. Sorry for that poor use of room here. Let me clean that up again. Whoever invented this? Yeah, it has its good points and its bad points for sure. Okay, so the square of the hypotenuse is equal to the sum of the squares of the legs. Okay, the square of the hypotenuse equal to the sum of the squares of the legs. So that means, so if I have a right triangle, the square of the hypotenuse is equal to the sum of the squares of the legs. Hypotenuse being C, the one that's across from the right angle, the legs being the other ones. So let's do this. Use the Pythagorean theorem to solve for missing sides of a right triangle. So our formula is the square of the hypotenuse is equal to the sum of the squares of the legs, or you could write it the other way, a squared plus b squared equals c squared. Order of that doesn't matter, but the hypotenuse, the c part of it, the longest side, the one across from the right angle, has to be the one that stands alone. So in this first problem, I would say leg 45 plus other leg 24 equals hypotenuse. And now I might need to take out my calculator and square the numbers like we did earlier. So 45 squared plus 24 squared equals, and I got 2601. I'm going to slow that down and do the work separately. I do 45 squared, get that answer, 2025, plus 24 squared, get that answer, 576. And then I take those two things and add them together. And then, just like to undo a square root, I would square it. To undo a square, I take the square root. So I'm going to take my other color and square root both sides. What I end up with then is x equal to the square root of 2601, 2601. Now, I don't want to just put a decimal down. And so if I plug this in the calculator, the square root, and I do the square root by doing the second key squared, the square root of 2601 comes out to be 51. So I get an exact answer and I am fine. I am done. I've figured out what my hypotenuse is. If I plugged this in and it came out to be a decimal, I'm going to have to do what we talked about yesterday and simplify my radical. So let's do another one. This one is 30 squared plus 40 squared equals x squared. So I do my math. That's 900 plus 1600 equals x squared. Add those together. 2500 equals x squared. Square root of both sides. And you should get 50. Good? Fine. What if I'm given the hypotenuse? Well, then my order of things have to change. So I can't just always automatically jump in and square the two things that I'm given and set it equal to the other. In this case, I have to look very closely. I know the hypotenuse. So this is going to look like 4 squared plus x squared equals 18 squared. How do I know when to set it up what way? I just have to be aware. Look closely. So 4 squared is 16 plus x squared equals, then I have to figure out what 18 squared is. Now I have to go back to my algebra days. This is why we take algebra before we do geometry. How do I solve this equation? Start by subtracting 16 from both sides. X squared is 308, I believe. Then I will take the square root of both sides. Plug that in my calculator. Oh no, it came out ugly. So then I'll go off to the side I have to do mine over here. Off to the side, I'm going to have to take the 308 and divide it repeatedly. Does 2 go into 308? Yes. What do I get? 154. Does 2 go into 154? Yes. What do I get? 77. Does 2 go into 77? No. Does 3?
No.
Does 5? Does 7?
Yes.
Great. So when I wind this up, when I'm all done, I take my pair of 2's out, and I leave the 7 times 11 in. So my final answer for x is 2 times the square root of 77. And you do need to, oops, that's so crooked, sorry. You do need to write them in simplified radical form. That's what the directions say. Leave your answer in simplest radical form. That's what that means. That means no decimal. Now, occasionally it'll ask you to round to the nearest tenth or round to the nearest hundredth, but right now the directions say simplest radical form, so that's how I want to do it. So let's go ahead and do our next one. Same way. If I could get this piece of paper off. All right. What's my setup? Yes. 5 squared plus x, oops, that's a plus, x squared equals 8 squared. I should just leave this stuff out all the time, huh? Except for that didn't really help on this one. Okay, so I'll go ahead and square 5. 25 plus x squared equals 64. Then I'll go ahead and subtract. Go back to my algebra days. Minus 25 minus 25. I get x squared equals, what's 64 minus 25? 39. Then I'll take the square root of both sides. I know it doesn't come out evenly, so I'm going to have to try to simplify this. So off to the side I take 39. Does 2 go into 39? Does 3?
Yes.
How many times?
13.
13. Does anything go into 13? Do I have any pairs? So I'm done right here as the square root of 39. That happens to be the simplest radical form. Again, I'm going to pause it. I would like for you guys to do E. We'll revisit in a little bit. And then we'll talk about Pythagorean triples. Go ahead and check your work with mine. Does anybody agree? Nobody? It's oh, so this should be 76. Okay, so this should be 76. So 38, 19. 2 radical 19 look better? Okay. You guys were awful quiet. All right. Any questions on Pythagorean theorem so far? Okay. Then let's talk about Pythagorean triples. What makes a Pythagorean triple? A Pythagorean triple, if you notice, some of our answers do not come out beautifully. If 4 and 18, if 4 is a leg and 18 is the hypotenuse, then 2 times the square root of 77 is the other leg. 2 times the square root of 77 is not beautiful. But if you look at A and B, we came up with nice answers for all of them. If you have a nice answer for all of them, it's known as a Pythagorean triple. And in fact, I have a whole list of Pythagorean triples on the sideboard. Those are all measurements of sides that could make a right triangle with perfect numbers. How can I check if I don't have those things memorized? Well, all I need to do is plug this into the Pythagorean theorem and see if it comes out nicely. Is it true that 6 squared plus 8 squared equals 10 squared? How do I know which one's the hypotenuse? It will always be the longest one. So 6 squared is 36 plus 64 equals 100. So 100 equals 100. Is this a true statement? Then yes, this forms a Pythagorean triple. So is 5 squared plus 12 squared equal to 13 squared? That's what we need to check. If it works, our answer is yes. If it doesn't work, we'll get some different information from it. We'll talk about that shortly. But before we move on, I do want to throw in some word problems. When we come to Pythagorean theorem, it's an application that is used a lot outside of the classroom. A lot. It's one of the more popular theorems out there in the real world. And so you're going to see some real world problems that show up time and again here when we're working. So sometimes you're going to have to draw pictures. Sometimes you're going to have to figure things out. Sometimes it takes us a while and you might have to read it a couple times. But my recommendation always is read the whole thing first, try to visualize, and then read it again before you set it up. So we have a window washer, has an 18-foot ladder. Think about what a ladder looks like. He needs to reach the bottom of a window 6 feet off the ground. That's supposed to say off the ground. How far out from the building should the base of the ladder be so that he reaches the bottom of the window appropriately? We need to round our answer to the nearest tenth. So I do not need to put it in simplest radical form. I need to round my answer to the nearest tenth of a foot. And so we're going to use the Pythagorean theorem. It tells me to substitute 16 for A, and let's draw our picture to see what 18 is. So I have a ladder. Here's a building. Here's the ladder leaning up against the building. Here's the base of the window. How tall or how high up is the window? 16. How tall is the ladder? 18. Where is my right angle in this picture? Bottom left. That makes 18 what? Hypotenuse. So we'll replace that for C. What I need to figure out is how far do I have to put the base of the ladder from the building? And so I can do 16 squared plus x squared equals 18 squared. One helpful tidbit of information when you're working on these, when we're doing Pythagorean theorem, all of your drawings will deal with the right triangle. You just have to make sure that you put things in the right spot. You can get as creative and clever with your drawing as you want. You can be as basic and rudimentary as you want as well. Because it said round, I'll just do the, square root. And nearest tenth of a foot, that's 1 decimal point after, so it's roughly 8.2 feet should be your final answer. Again, just pay attention to how the question needs to be answered. Pay attention to the directions. Any questions or comments? Yes. Oh, so for you, there is a little key above the above the enter button, and so you just hit that. Oops. Okay, so you hit this. So it's just that arrow. Okay. All right. Let's check to see if each triangle is truly a right triangle. What's the dead giveaway that it's a right triangle? That Pythagorean theorem will work. It doesn't have the right angle in it, but I can still assume that across from what we think the right angle might be would have to be the hypotenuse or the longest side. So I can't guarantee that this is a right triangle yet. I'll plug it in my calculator to see if it comes true. Just like we were checking Pythagorean triples. If the Pythagorean triple came out true, we knew it was a right triangle. Basically what I'm doing is trying to see if this is a Pythagorean triple. So I'd get 64 plus 225 equals 289. So 289 equals 289. Are they equivalent? Yes. Therefore, I can put a little right angle in that triangle. I can say, yes, this is a right triangle. So let's try our next one. Is 36 squared plus 27 squared equal to 45 squared? Remember, the longest side will always be the hypotenuse if this is in fact a right triangle. Came out true, therefore I can put in my right angle. This is, yes, a right triangle. Let's try our last one. Is 4 squared plus 9 squared equal to 11 squared? Is 16 plus 81 equal to 121? Are they the same? No. Not a right triangle. Did not come out true, therefore not a right triangle. But if it doesn't come out true, that tells me something. It lets me know, first of all, that it's not a right triangle, but we can use that information to help us out. And so if you look at our next statement, if c squared equals a squared plus b squared, we know that the triangle is a right triangle. But if c squared ends up being larger than, this means more than, greater than. If c squared is greater than the sum of a squared plus b squared, then we end up with an obtuse triangle. And if the longest side, c squared, is less than the sum of the shorter two sides, then I know triangle ABC is an acute triangle. So we're going to classify the next ones as acute, obtuse, or right? Let's go through. We're going to stop here. So we'll work through 4 of them. So I'll start with the longest side squared and compare it to 3 squared plus 8 squared. That's 100 equals 9 plus 64. 100 equals, what is that, 73? Equals is not correct, therefore it's not right. How does it compare? It's more than, therefore obtuse triangle. Up next, 26 squared compared to 10 squared plus 24 squared. Might have to pull out my calculator. Came out equal, therefore right triangle. Again, I'm going to pause the video and have you try the last 2. What's that? Are you sure? You're sure you figured it out? I wasn't sure what you were asking with that. Okay. We'll refresh the last 2 when we get back to class. But this is it on Pythagorean theorem today. So your job is to do homework.